Let's understand about extrinsic semiconductors. Now, before that, there are a couple of things you have to understand. Before you understand what is an extrinsic semiconductor. Okay. Now, in that, let's talk about the electrical conductivity in a semiconductor. Now, in an intrinsic semiconductor, we understood that number of holes and number of electrons, both of them are one and the same. And they are the ones who carry the current, isn't it? Now, when it comes to electrical conductivity, in an intrinsic semiconductor, the number of charge carriers, that is the electrons and holes, they are one and the same. So, the total current, whatever is there in a semiconductor, it has to be the sum of the electron current and the hole current. So, mathematically, I is equal to IE plus IH or IH plus IE, both are one and the same. Now, for an intrinsic semiconductor, since the number of holes and electrons are equal, the net current is going to be very, very small. It's a very low current. So, it's not very efficient to have an intrinsic semiconductor. And all the more, getting a pure semiconductor is very expensive. Okay. That's why intrinsic semiconductors are not used, or it's not preferable. Now, what we do, we add impurities to it such a way that it increases the electrical conductivity. Now, this is what we call as doping. So, doping is that phenomena where we add suitable impurities to all these semiconductors in such a way that their electrical conductivity increases. Okay, so this is what we call as doping, or this phenomena is what we call as doping. Now, even when we are doping also, there are certain points what we have to keep in the mind. Okay, like, okay, I have a silicon crystal, just keep on adding the dopant. No, it doesn't work that way. Okay, now the impurities what we add, we call them as dopant. So, the dopants, whatever we are adding, there are certain rules in which you have to add. You can't just keep on adding it. Now, generally, the dopants what we add is in terms of parts per million, ppm. Like 1 ppm, 2 ppm. That's the way how we are going to do it. Okay. Once you add a dopant to the semiconductor, that is what we call as extrinsic semiconductor. Okay. So, this is what we are looking at. That means when you add impurity, desirable impurity to an intrinsic semiconductor, we call that as extrinsic semiconductor. Now, what are the things we have to keep in the mind whenever we are adding these dopants to the semiconductor? See, the first one you guys already know. That is, the quantity should be less. Like it should be in terms of parts per million. That means for 1 million, the crystal, whatever that silicon crystal you have, silicon or germanium, there should be one impure atom. Something like this. So, it has to be in terms of parts per million, ppm. The second one is that, see, when you add an impurity, it should not change the structure of the crystal. It should not distort. Okay, now generally, every crystal has a particular shape and structure, like it is face-centered, body-centered, something like this. Now, that structure should not change because you are adding an impurity to it. That causes a lot of other issues. That's why this structural integrity should always be the same. The next one is the size of the dopant, whatever we are adding, it should be similar to the size of the semiconductor atom what we have. Okay, now for a small atom, you cannot add a very large, big size impurity. Then obviously there's going to be distortion in the crystal. That's why we don't add such things. The size should be comparable. Okay, and the next one is, like I told in the first point, the parts per million part, the same thing, but in terms of percentage. That is, the impurities what you are adding, it should be very, very, very less. That is less than 1%. Clear? So, this process of doping, that increases the electrical conductivity by a lot, actually speaking. Okay, by a lot. So, whatever the semiconductors we get, they all are extrinsic semiconductors because they're all doped with some or the other impurity. Now that you know there is doping, then that means you know that there is an extrinsic semiconductor. There are two types of extrinsic semiconductors. We'll look into that in detail in the next video.